Hello and welcome to this video about kinetic energy. Kinetic energy is the energy that is transferred by moving objects. And we have this equation that we can use to calculate kinetic energy, and that's kinetic energy is half times m times v squared. And this is how you'll get it in your exam, and this is what the letters stand for. EK is kinetic energy, m is mass, and v is velocity. And this is how it will be presented on your exam paper. So you've got kinetic energy, mass, and speed, it calls it, or velocity. And of course it doesn't give you the unit, so that's something that we'll have to remember. So let's go through the units first of all. We've got energy, so any type of energy is measured in joules, which is a capital J. Mass is measured in kilograms. That's the standard unit for mass. So if you see the mass in grams, you have to convert it first. I'm going to put this here to remember. If you see the mass in grams, convert it to kilograms. Okay, I'm certain that people will fall up on this, even if you watch the video and do the questions that I set you out in a minute. It's something that always leads people to lose a mark in the exam. You have to put it in the standard units. Velocity then is meters per second. So those are the units we're going to look at to be calculating kinetic energy in these questions. So first of all, there's a couple of questions here. If you just pause the video, have a go at them, see if straight away that you can put them in this equation, and then come back and see if you've got the answers right. So again, it's important to highlight all the information we get. So the first one, what is the kinetic energy? That's what they want you to work out, of an 800 kilogram roller coaster carriage that is moving with a speed of 20 meters per second. So again, it's good practice to highlight the numbers that you've got and indicate what they are. So that's mass, and this is velocity. And then we should just be able to put the numbers in this equation. So we copy it down first of all. Half times m times v squared. So kinetic energy is half times 800 times by 20 squared. And if you put that into your calculator, it should give you the kinetic energy. So we've got 0.5 times 800 times 20 squared, which gives us 160,000 joules. Don't forget your units. There's often a mark for units in these type of questions. For the second one, what is the kinetic energy? That's what they want us to work out, of a 75 kilogram woman running with a speed of 2 meters per second. Always good practice. That's right, that's the mass, that's the v. Write the equation down. EK for kinetic energy equals half times m times v squared, which is half times 75 times 2 squared. Pop that into your calculator. 0.5 times 75 times 2 squared equals 150 joules. Okay, so we're lucky on this one. They're all in kilograms and meters per squared, all the units we wanted to, so we can just put the numbers into the equation. Okay, so if you've managed to do these questions, then very well done. They're often worth 2 or 3 marks, because you've got to do some calculations and remember to include your units and things like that. What I want to introduce to you next is questions that are only worth 1 mark, and I want you to be able to look out for these and know what to do when you get these 1 mark questions. So where these 1 mark questions tend to come around is when the question links 2 types of energy. That's gravitational potential energy and kinetic energy. I'll cover gravitational potential energy in full in another video, but I want to introduce it here because it's important to talk about both types of energy at the same time. So here's a couple of 1 mark questions that you might see in your exam. This says the gravitational potential energy of the woman at her highest point is 500 joules. Calculate the kinetic energy as she hits the trampoline. And this is 1 mark. Now what I want you to get into your minds is the idea that if it's 1 mark, the examiner won't be asking you to do a massive calculation. And if it's 1 mark, you tend to just have to regurgitate the number they've given you. So I know straight away by looking at this that the answer to the question is 500 joules. And I'll just explain why. When an object is raised, it gains gravitational potential energy. So we can write that as EP for gravitational potential energy. So at her highest point, she has a gravitational potential energy of 500 joules. And we need to know that as she hits the trampoline, all of that gravitational potential energy is turned into kinetic energy. And that is why the gravitational potential energy of 500 joules she got here is all transferred into kinetic energy. So as she hits the trampoline, she will have 500 joules of kinetic energy. And this will be the answer for 1 mark to our question. So this is a key important point. When objects fall, all the gravitational potential energy is converted into kinetic energy. Okay, so it's 1 mark. They've not asked you to do a massive calculation or anything like that. They're asking you to understand this bit, that all gravitational potential energy is converted into kinetic energy. So by the time she hits the trampoline, all of that energy that she stored up there is transferred into kinetic energy. Let's look at it in the second example then. We've got a roller coaster moving from position X to position Y. It says the gravitational potential energy of the roller coaster at point X is 800,000 joules. So up here, gravitational potential energy is 800,000 joules. And it says calculate the kinetic energy at point Y. And if you look again, that is just 1 mark, and that should be alarm bells to you to think I don't have to do a massive calculation, but I need to understand that all the gravitational potential energy that is stored in an object is transferred to kinetic energy. So at point Y, the kinetic energy would be 800,000 joules. So really look out for those 1 mark questions, because that could be the crucial mark that you need to get the grade that you want. Okay, so for foundation tier, that's all we need to be able to do with kinetic energy, be able to use this equation by highlighting the information that you get in the text and putting it into the right equation, and then understanding this point that we've just discussed about gravitational potential energy transferring into kinetic energy. I'm now going to introduce some of the higher tier content, so keep watching if you're doing the higher tier. Okay, so for those of you doing the higher tier, this is where things start to get a little tricky, and in my opinion this is the most difficult rearrangement of an equation that you've got to do in the GCSE, and you might be required to rearrange this equation here to make it mass equals or to make it speed equals, for example. So let's have a look at the question we've posed with, and we can work it through step by step. So we've got the gravitational potential energy of the roller coaster at point X is 800,000 joules. So again, good practice. Highlight the bits that you got and draw over any diagram that you're given. So gravitational potential energy is 800,000 joules at this point. And it says the mass of the roller coaster is 8,000 kilograms. So I check it's in kilograms. It is. So I can just write the mass. And then it says calculate the velocity of the roller coaster at point Y. So I need to work out speed. Okay, so this is really tricky. I'm going to have a few things going on here which I need to work out. First of all, I need to change the subject of this equation to make it V equals. So if I break that down over here for you step by step, first thing we can do is divide both sides by a half times m. So if we get rid of that bit, we end up with, so divide both sides by half times m. Over here I'll write it, we end up with kinetic energy divided by a half times m equals v squared. Okay, now we can't just leave it in v squared, we have to do one further thing. So to get rid of that v squared, we need to square root both sides. So square root that side and then square root this side of the equal sign. So we end up with the square root of kinetic energy divided by a half times m equals v. So a really difficult rearrangement of the equation that we've got to do. You don't get given this rearrangement in the exam, you just get given it like that on the data sheet and you will have to rearrange it yourselves. So that's the first thing we need to do. So we've got v equals the square root of kinetic energy divided by a half times m. Okay, so can we work it out? Have we got a mass? Yes, we do. Have we got kinetic energy? No, we don't. We only have gravitational potential energy. Hopefully you'll be thinking to yourselves, if I look at the roller coaster at the top, all of that gravitational potential energy that you've got will be transferred into kinetic energy at the bottom. So the kinetic energy at Y equals 800,000 joules as well. This is the type of thing they'll do in the higher tier to make it really tricky for you. So you'll have to remember for this question how to rearrange the equation and the idea that the gravitational potential energy is transferred into kinetic energy. So now we've got all our factors, we can put it into the equation. So we've got V equals the square root of 800,000 divided by half times 8,000. And if we then put that into our calculator, we will have 800,000 divided by 0.5 times 8,000, and then we have the square root of that answer, and it's 14 meters per second as the speed of that roller coaster at the bottom. Okay, so once you've found the correct numbers to put in and put them in the equation, then you can just calculate V by putting the numbers into your calculator. So let's put your knowledge to the test then. Here are a couple of higher tier style questions for you to try. If you pause the video, work the answers out for yourself and then come back and see if you got them correct. How you get on. So let's see how you got on then. Let's go through this first one. A diver has a kinetic energy of 10,000 joules. So straight away you should be writing all over your paper and saying that that's the kinetic energy just before hitting the swimming pool. If the mass of the diver is 50 kilograms, so I'll write that down as mass, check it's in kilograms, yep, then what is her speed as she hits the water? So I know that I need to calculate V equals, so I need to rearrange my equation. So you should have rearranged it, so V equals the square root of EK divided by a half times M for mass. And we need to put our numbers in. Have we got kinetic energy? Yes, we do. Have we got mass? Yes, we do. So V equals square root of 10,000 divided by 1/2 times 50. If you put that into your calculator, I always recommend to do this calculation first and then square root the answer. I just find that easier. 10,000 divided by, in brackets, 0.5 times 50. If you don't have those brackets, the answer will come out wrong. And then the square root of that is 20. Okay, so we can write V equals 20 meters per second. If you don't have your units, you'll drop a mark. So next one then, a book sits on the top of a bookshelf. The gravitational potential energy of the book is 100 joules. The book falls to the ground. The mass of the book is 200 grams. So alarm bells are ringing here already that it's 200 grams. So we've got the gravitational potential energy, the mass, but it's in the wrong unit. And we need to calculate the speed as it hits the ground. So again, we need our rearranged equation. V equals the square root of kinetic energy divided by 1/2 times mass, and we need to do another step because we need to convert that mass into kilograms. So we need to do divide by 1,000 to convert it into kilograms. So 200 divided by 1,000 is 0.2 kilograms. We can just move the decimal place back 3 places. So now we've got it in kilograms. Okay, we should be happy with that. So we can now put it into our equation. So V equals square root of kinetic energy. And then we look in our question and think, we don't have kinetic energy. They've given us gravitational potential energy. Well, if you think about the book on a shelf, that's the book. Remember, if it's got gravitational potential energy that it's storing at the top, that will all be transferred to kinetic energy when it hits the bottom. So actually the value we've got here for potential energy is also the value that we can use for the kinetic energy when it hits the ground. So V equals the square root of 100 divided by 1/2 times 0.2. So if we do that on our calculator, we've got 100 divided by 0.5 times 0.2 in our brackets again, and then the square root of the answer will give us 31.6, which I'll round up to 32 meters per second, and that is our speed at which the book will hit the ground. So very well done if you got these two answers correct. If you used the 200 here, you'd have got an answer of 1 meters per second, and you probably would have dropped 1 mark on the exam. But every mark counts, so do try and remember to put the numbers into their standard units before putting them into the equation. So if you found this video useful, then please press the like button and subscribe. Thanks for watching.